So now all another great question. So why is it that some atoms or elements don't seem to obey the octet rule? And the short answer is that they don't have to. It's not a real law. It's just a little trick that we use to simplify diagrams or to draw simple compounds quite efficiently and fast, right? But they don't have to actually obey the octet rule, right? It really breaks down to what is most energetically favorable for the electrons involved in the bonding process. So for some atoms, depending on the situation that they're in, it might be more energetically favorable to fill up those shells. In other scenarios, depending on how the electrons are quantized, right, meaning like how much energy they currently have individually, it might be more favorable for them to not fill up the shell with 8. So if you think about compounds that involve boron, like boron trifluoride, that has less than 8 electrons in its final shell, but that's a stable compound. But if you think about other compounds that involve sulfur and phosphorus, often they need more than the typical 8 electrons in their final shell in order for them to be relatively stable. So whatever is more energetically favorable, that's what's going to happen. A way that you can typically measure these, you can use formal charges, okay? And I'll make another video about what those are, or you can use oxidation numbers if you're dealing with ionic compounds. But long story short, they don't have to obey the octet rule. It's not really a rule, it's more of a trick.